everyone. I'm Ashley McManus, Senior Director of Global Marketing at SmartEye. Welcome to the Human-Centric AI Podcast, where each episode we feature thought leaders doing cutting-edge work in the AI space. A little about us. SmartEye is the global leader in human insight AI, technology that understands, supports, and predicts human behavior in complex environments, bridging the gap between humans and machines for a safe and sustainable future. Today, our tech is embedded in next-gen vehicles, leading the way towards human-centric mobility through driver monitoring and interior sensing solutions. Our research instruments offer unparalleled insights into automotive, aviation, assistive technology, behavioral science, and many more fields. Today's episode features Matt Straffus, Director of Product and Customer Solutions at Affectiva, now a SmartEye company. Matt has been with Affectiva for almost 10 years in various roles. Affectiva, the pioneer of emotion AI, was acquired by SmartEye in 2021 and has since continued its strong brand presence in the media analytics space. With a degree in physics and computer science, Matt has worked on everything from software development, project management, customer success, and everything in between. His deep expertise in the space made him a natural candidate to interview about the new Affectiva Calibration-Free eye tracking feature, which represents a culmination of the SmartEye eye tracking tech and Affectiva Emotion AI just announced this week. Matt and I talked about the development of this feature, how it's differentiated from other eye tracking and attention measurement solutions on the market, some high-level mechanics on how it works, and where we may be going with it in the future. Let's listen in to learn more. Okay, hi everyone. Thanks for tuning in. With me, I have Matthew Straffus, Director of Product and Customer Solutions at Affectiva. Matt, thank you so much for making the time to speak with me today.
Thank you for having me.
Absolutely. So we've had you on the podcast before, but to start, why don't you tell us about your background and how your career path has taken you to Affectiva in your current role?
Sure. So, my background is actually in, I've got backgrounds in physics and computing, and many years ago thought I was going to be a physicist. But for a variety of reasons, at some point or another, I decided, all right, let's go back into the computing aspect and got involved with startups. And after a couple of different startups, ended up landing a position as an integration engineer with Affectiva, and have slowly over the years occupied almost every position inside the media analytics business unit of Affectiva, all the way through until our acquisition by SmartEye, and now kind of continue to connect the dots on the media analytics side.
Nice. So for those who are unfamiliar with Affectiva, now a SmartEye company, as you mentioned, can you briefly explain what our offerings are for the media analytics space?
Yeah, so media analytics space is let's call it the classic offer out of Affectiva. The original business use case was to evaluate emotional response to advertising content. And that's where Affectiva kind of stepped in. We actually kind of broke ground on that market and introduced the technology for the first time to the space in the kind of low touch computer vision kind of way. So in the experience now, individuals who are participating in a research study may at some point in time be asked permission if we can record them while they observe an advertisement. We'll present a consent question that identifies exactly how we want to use it for emotional insights and analysis, and links them to kind of privacy policies. We try to operate as transparently as we can with them. And assuming they consent and say yes, we then turn on their camera and create a face recording of them while they observe the advertisement. And when the study is done, the results of those analyses, which is just raw data of their emotional experience, gets effectively, we use fancy words like aggregated, but effectively gets averaged with all of the respondents that had observed that advertisement to present kind of a summary of a population report in their response to the stimulus.
Awesome. Great. So let's dive into the topic of the podcast. So we just put out this announcement around a new feature called Calibration-Free eye tracking. I wanted to ask you about what motivated the development of this feature, and given your background, what specific challenges in measuring viewer attention for brands and entertainment companies did you really aim to address with this feature?
Yeah.
So kind of a loaded question, but let's kick it.
No. Calibration-free eye tracking has been a dream. This has been on a wish list for officially 4 years, unofficially probably more in the realm of 6 to 8 years, that we have continually identified this issue of disruption to the survey experience. So if you think of kind of taking web surveys inside a media analysis environment, this is akin to almost a scientific experiment. And the more measurements that you make in a scientific experiment, the harder it is to avoid adversely influencing the subject. There's other examples of this in kind of the sciences and the physics background that I have. There's a great example of this that's something I reference periodically. But effectively, the more you add into a study to make measurements on the people, the more we're going to influence them. And webcam-based eye tracking is definitely a spot where you do that. So for anybody who has done anything like this before, you should be familiar with this exercise where a dot pops up in corners of the screen or moves around the screen, and you follow it around, and it takes away, it's going to sound funny, it takes away a minute of your life. Yeah. You'll never get it back. And maybe there's a post-calibration exercise. So you'll do that and you'll watch the ad and then you'll do it again because we love to do that again. There'll be a whole other minute that pulls you out of the experience of thinking about the advertisement so that you can properly digest how you thought to answer the survey questions. So it is definitely the prototypic definition of adding a measurement that adversely affects your audience. Years ago, when Affectiva first introduced the idea of the emotional analysis, one of the real wins was quite literally the only thing that we needed to do to attain this analysis was to have people turn on their camera and make sure that they were in the frame of the camera. So the severely low touch of that implementation was a real win. So anytime we try to partner with someone that offered eye tracking in some way or form, it feels like we kind of robbed ourselves of that win. So at some point, roughly 4 years ago, we started to play around with the idea of, hey, if we captured enough data, we don't have to be, it started with, we don't have to be as accurate as the webcam eye trackers. We just have to get maybe if the four corners and the center screen, if we can distinguish those, maybe that's really great, but then without calibration, we can kind of get that overlaid. But with the acquisition and Smart Eye becoming our parent company, whom are, for anyone not aware, here Smart Eye makes some really great eye tracking technology. It presented this really wonderful opportunity to really pry into some foundational eye tracking tech with some of the Affectiva startup ingenuity. And despite the fact that Affectiva is not a separate entity anymore, despite the fact that there's no startup anymore, that ingenuity is still there and it's still hungry. So this presented an opportunity that was all too tempting for us to pursue and see if there was a way to just track the eyes without being dependent on people going through this exercise.
So I was hoping you could explain, get a little bit technical as to how this calibration-free eye tracking works. And I think you touched on it a little bit, but for listeners who aren't familiar, why this is such, why does this eliminate the need for traditional, the calibration process that you described and what that means for the end user experience?
Sure. So there's two ways to look at this. We can approach this from the experience of the survey participant, the respondent. We can look at it from the perspective of the research insights to be found. What this does from a survey participant's perspective is it eliminates one more careless exercise. Right? The length of your survey is going to dictate the compensation that a survey panelist has to take. Right? No one wants to put in more time than they have to without being more compensated. So you could save a little money here by keeping the survey experience shorter. But no one wants to go through this fruitless exercise, or from an individual's perspective, a fruitless exercise. As a survey respondent, I don't want to follow these dots. That's annoying, but I got to follow these dots because I have to follow the dots. And so after getting kind of, I might be exaggerating this a little bit, but after getting fatigued with that 1 minute process or 1:30 process, however long it is, depending on whatever platform you're using that requires to gain calibration, and kind of being bored, for lack of another term, you then kind of need to sit still for the emotional response period when you're watching the advertisement. So this can kind of, this does a few things. It pulls the individual out of their natural experience while watching a piece of content. And I keep saying advertisement. It doesn't have to be advertisement. It can be, TV shows. It could be theatrical trailer testing or whatever it happens to be. This exercise is going to break your zen before you go in. And so there's kind of this realization of this consciousness that becomes perturbed, especially if you're kind of asked to roughly sit still while we track your eyes moving around the screen. So that's one. As a survey respondent, you can relax. You don't need to be paranoid. You can reposition. You can shuffle around. As long as your face is in frame, the technology will work. It's very similar to the emotional capabilities. So from a researcher's perspective, the advantages are huge. It's funny. Oh, it's just eye tracking. Everybody's eye tracking's been around for years. Who cares? This is different. As I had already mentioned, it shortens the survey length. So yes, the cost to implement it may have some implications. Furthermore, the number of respondents that we can capture with usable data within eye tracking is higher, because the likelihood of falling out of calibration is decreased. There's a little bit of almost a deception here. There's going to be too many words here. A more accurate description of this is calibration exercise free. So a respondent does not need to go through the exercise of calibration.
Yeah.
It's not to say there isn't actually a calibration happening. It just so happens calibration is happening dynamically as you have the exposure. So each frame that is captured from the camera is pumped through a real world model to adapt to the location and positioning of the individual. This creates a scenario where we're not dependent on a predisposed position of the respondent during an exercise to calculate where they are looking in the future, which means the data that we can preserve over the period of time for individual respondents increases. The number of usable respondents to create a robust heat map increases. As a result, you may not need to capture as much sample to get usable eye tracking results that you might have in a traditional eye tracking setup. Furthermore, from a researcher, webcam-based eye tracking tends to have a tail off, right? Again, we've talked about people falling out of calibration. We talked about people repositioning being. Webcam-based eye tracking tends to be limited to kind of shorter form, mostly ideal advertisement, 30-second content, stuff like that. You can see people go up as high as 3 to 5 minutes, but anyone that's kind of built these kind of webcam-based systems gets really hesitant once you start to get past 5 minutes. That gets into really gray territory.
Yeah.
Well, what does that mean? It means anybody that's trying to test a TV show through an online survey environment will never be able to use webcam-based eye tracking. Well, what happens if you don't become dependent on that calibration exercise anymore? Suddenly, the longer the content goes, the more our accuracy becomes better. It's not that our accuracy improves over time. It's that our accuracy holds steady over time, where calibrated accuracy may start off really well, but will drop off very quickly. And so over time, for longer experiences, you can suddenly get an idea of, hey, did they pay attention to the branding out of this incredibly long Super Bowl ad that we paid an enormous amount of money for? These high-risk situations where we're dumping a lot of money in this. Let's make sure it gets the point. Did they see what we wanted them to see? There are some wonderful ads that we've tested this stuff with along the lines of having a celebrity promote a product. And as it turns out, if the product's on one side and the celebrity's on the other, they don't look at the product. They're looking at the celebrity. And obviously, the product can't tell a bad joke. The celebrity can't do it. It's kind of be expected, so that's an obvious example. But these kinds of things are now prominent with longer content in our capabilities. So we can now start to identify what they're looking at in addition to when they are emoting. This starts to open up a door for a multimodal analysis. Right now, I'd still consider this kind of bimodal. Yeah, there are two different modes, eye tracking, emotion tracking. They're still being presented in two different formats. Here's your eye tracking results. Here's your emotion results. I do see a scenario in which these start to be folded in together from a researcher's perspective. And from there, the sky's the limit.
Yeah, definitely. It's so exciting. So when you talk about the different challenges in developing this, calibration-free eye tracking, can you share some insight, if you have any insights into the technical and some of the logistical hurdles that you faced when building the world models, as you touched on, necessary for this feature?
Sure. Yeah. So this is definitely one of those scenarios in which you're reminded that some of the things that you do on a daily basis are considered science fiction by some other people. If you recall from our previous conversation, we had talked about kind of the acquisition of Affectiva by Smarta, creating the potential for this new AI powerhouse. We talked a lot about the merger of the two technologies, what they could do in the previous conversation pertaining to attention. That conversation evolved around marrying the core Affectiva SDK with the foundational smart eye tracking technologies. Now, we couldn't actually implement it as eye tracking at that point in time, right? There's no means to line up what data it's getting from the eyes with the viewport that the individual is looking at. So this became kind of an attention that was built out. We would normalize over the audience to determine, or not the audience, we would normalize over the experience to identify kind of how attentive individuals were. So we could tell when they were looking at a separate screen that didn't have the content or things of that nature. This is another piece of technology stacked on top of this. So if you start to think of the world in the generative AI now, we're getting a lot of power out of kind of pairing up specifically tuned generative AIs to kind of work together to do various tasks. This is kind of in that vein. What we have done now is, in addition to the core Affectiva technology and some foundational smart eye technology, we have built out and trained an additional model system based on information that we can obtain about the device, as well as information we can attain from facial positions relative to the camera over time, to dynamically calibrate the appropriate angles to determine where someone is looking at any given moment in time. So it's a much more dynamic process than what's been done before. I'm not going to sugarcoat this. This is a very heavy design. It's definitely something that is well worth what it took us to do, right? It took us some time to get this out. It's all of that time was used wisely. But the objective here was then, in theory, not necessarily to match what could be done, but it did end up eventually matching what was done with webcam-based eye tracking. But the weight on this then now kind of does this heavy thing, and it's to the point now where we can't actually do this real time. This is definitely a post-process maneuver, which kind of makes it really well fit in our current portal application, where it makes kind of a post-processed routine anyway.
Yeah.
But that post-processing gives us this advantage now to kind of monitor the entire behavior of the individual through the experience. And through that combination of knowing the behavior of their whole experience, in combination with a variety of the outputs from the SmartEye technology, the Affectiva technology, and a training set and this foundational world model, now gives us something that is very, very close to the traditional webcam-based eye tracking without the calibration exercise.
Mm-hmm.
I'm very sorry, that was very long-winded, but I hope I got your answer there.
Nope, I think you covered it. One thing I also wanted to touch on was the impact of this on accessibility and inclusivity in research. So, given its scalability and the diversity of the training sets used, how would you say this calibration-free eye tracking ensures consistent results across different demographics and locations?
Mm-hmm. So it's interesting, the Affectiva foundational emotion AI set, we always kind of point to this extremely large data set that we've accumulated over the years, and the process of kind of diversifying our training set to make sure that we can mitigate any biases in cultures or genders or what have you in kind of the emotional technology analysis. This turns out to be a little simpler because eyes are eyes. So to that end, the diversification, it's not to say that we don't need to take precautions. We do,
Yeah.
but the precautions had the similar advantage to the existing training set that we had was immensely diverse. So while we didn't explicitly tune or train with a targeted diversity set, it inherited the diversity that we had kind of included in the upstream technologies. And with that, we now get kind of the same capability. In addition to that, this brings kind of more robustness in a different way. So if you think of individuals that are tired, right? They're trying to like desperately get through this, or individuals that are sighing and leaning around or for whatever reason can't sit still. This could describe me in some circumstances. Very hard time mimicking it in the same way. But if you consider high energy individuals versus let's say sit still individuals, this can now eliminate or work toward eliminating any bias between those two, because the high energy individuals are more prone to kind of fall out of the calibration with traditional sets.
So, and I know we just launched this today. It's very early, but I'm curious if you have seen any initial feedback from early users or partners, any reactions or insights that have already experienced this feature, or any surprises, anything that surprised them the most about this.
What was amazing is that we have cheated and exposed this to some select partners. Their initial reaction is, great, because they think we've used some kind of a predictive generative AI heat tracking system. There's a variety of providers out there that do this, and there are very obvious failure positions, like the predictive eye tracking will not follow the direction of where a character is looking. So I remember there was a case study done by, I forget the provider, but there was an M&M's ad where the yellow M&M was like baking. And as he was rolling dough on the table, the real eye tracking results revealed that the audience was watching what he was doing versus the predictive eye tracking was looking at the face of the M&M.
Okay.
So these kind of obvious touch points are kind of known inside the generative heat tracking or generative eye tracking space. So there's a variety of initial reactions like, yeah, but generative heat tracking is already out there. Who cares?
Yeah.
And then there's the moment when they realize we said, no, this is tracking individuals. Just said, wait, you've recreated one of our studies. Did you refill this? And then the true weight of realizing that we used the original captured fieldwork to produce this result, which is immediately followed with almost confused skepticism. This is kind of along the lines of, no one's ever tried to get something out like this before, so no one's even considered it as a possibility. They all just make with I want eye tracking, so let's follow the dot around the screen. So that reaction is really interesting. In fact, there are some studies captured a very long time ago that we have had explicit permission to hold on to the face videos for, that we're able to reprocess and produce insightful heat maps. So information from many years ago, or studies done many years ago, we're getting new insights out of with this data.
Wow.
So praise. And when we start to do that with some of our research partners, there's a level of shock that I don't know we know how to measure yet. In fact, in the next we commit a Motion AI update, I may try to sneak in some measure of shock, because we have great examples from this.
Nice.
There is also a provider that likes to test TV episodes with us. We thought, giggles, let's see what happens when we test this on a 30-minute sitcom. Or I guess more like 24 minutes, but whatever. It fits a half an hour time slot. the conversation with them started with, yeah, we'll see it. And as we started, and as the results continued to make sense and continued to call out interesting things about what they were seeing, it went from, okay, whatever, to, can you really do this? Is it real? So there's this wild thing, but we've had to do a variety of things to kind of prove to them that no, this is genuinely real. We're measuring actual individual eye tracking results. This is not generative in any way or form. And I think that's been the biggest response here. Is there's a disbelief that's so extreme that they think that this is a predictive heat map instead of an actual heat map. But with that being said, it's starting to open up all sorts of new avenues and conversations with these providers whom thought they would need to get a specialized device to be able to test longer, strange content.
Mhm.
So, I talked about kind of a long Super Bowl ad. That's on the short end of what we can do. I mean, what would happen
Mhm.
if we tested Lord of the Rings with eye tracking? I mean, that's not even something you could think about doing on a webcam prior to this tech.
Yeah, definitely. So interesting. So now I have to ask about the future. So how is this evolving within Affectiva's roadmap? What are the next steps for this type of technology? How do you envision it? How do you envision that in its role in the broader context of emotion AI?
Yeah. So, I mean, the interesting thing is that we realize we know an awful lot about emotion AI, and we are just learning the little bits in the beginning with eye tracking. So, what we're releasing here today is effectively what we would consider version one. It's not to say that like version two is about improving the results of the eye tracking. Version two is improving how you can use the results. So right now, I talked about this a little bit earlier. We kind of have this two modal input, right? The emotion and the eye tracking, and they're being presented in kind of two communication channels: the eye tracking and the emotions.
Mhm.
What happens if we start to produce eye tracking results or kind of a heat mapping eye tracking result when people are smiling? What happens if you're producing heat tracking results of, let's say, brand users versus non-brand users? The dynamically, Once we start to dynamically split the eye tracking results out by things like our emotional metrics or by perhaps some survey responses, now we start to get into some really weird territory. What if we tie this in with object recognition? All right, you find out, oh yeah, no, there's this moment of disgust, but there's a puppy playing with the ball. Yeah, you turn on, emotion-based heat maps. Yeah, you see the people looking at the puppy are smiling, but the people looking at the toddler smashing a cake on their shirt are disgusted, or whatever it happens to be. And suddenly you can parse out different events and complex scenes,
Oh, wow.
which could make it really interesting to kind of get into detailed conversations about what went wrong with the ad or what went right with the ad if there was an unexpected result. Anytime something happens of abnormal extent, this gives us a lot more certainty to kind of narrowing down what this could be.
Awesome. Okay. So we've covered a lot of ground today. My last question for you is around, is there one key takeaway that you want listeners to remember about this innovation? What's the most important thing they should take away and understand about calibration-free eye tracking and its potential impact?
I think it's important that we frame this in the context of the modern era of generative AI. When you use AI to predict how people will respond, instead of using people in a research study, you are making a prediction on your prediction. As you recall, the use of people in a research study is predicting how the market will react to something. So predicting how your prediction will behave will propagate some meaningful error into your results. We already talked about the M&M's ad where they were looking in the wrong place. Like, what if this happens in a critical scene? I mean, this is the obvious example. What happens with the non-obvious example? How critical is this? What will that do to a brand if they get it wrong? This gives the same kind of low touch, ease of use result on real survey respondents. So we're not at the prediction of prediction level. This is just the prediction level and is thus prone to less of that error. And if we build everything on what we can predict with predictive eye tracking, then what happens when something happens that we can't predict? So this really enables that capability without all the added weight of the webcam-based experiences of the past, which required individuals to sit still, pay attention, follow this dot, and exercise all of those things. They can observe in a more natural state, and we can get accurate results.
Awesome. Excellent. Well, that is all I had for you today. So, Matt, once again, thank you so much for your time. It was a pleasure speaking with you again.
Thank you very much for having me. Always a pleasure to be here.
A staple of the Affectiva organization for many years, Matt is passionate about delivering best-in-class, accurate, and easy-to-use technology to our customers. Though it has been 3 years since acquisition, Matt and the Affectiva team have been hard at work leveraging the precision of the Smart Eye tracking tech for our media analytics customers, and it's really exciting to see this next installment come to fruition, which much more to look forward to. I hope you enjoyed today's episode, so don't forget to subscribe to the Human-Centric AI podcast on iTunes, Google Play, Stitcher, or wherever you get your podcasts for new episodes. We're also on social media, so please reach out to us on Twitter, Facebook, LinkedIn, and Instagram to share any feedback you have on the show and weigh in on the discussion using hashtag Human-Centric AI podcast. Don't forget to rate us and comment with your feedback to help make the podcast more discoverable for others. Until next time, thanks for listening.